Alrighty, so right now we are sitting on Thursday right here. SLT 15, construct exponential functions. We're going to be talking about this. Tonight's homework is number 1 through 6 here. So make sure that you watch this video. You can watch it again. You can rewatch it however many times you would like to help you out with that. So if you'll turn to page 15 in your packet for me. And right now, we got a little math mug right on the inside there. Mathematics. That's right. A little coffee. That's good stuff. All right. So here's our warm-up on page 15. It says, what can you determine from the equation f of x equals 3 times 1/4 in parentheses to the power of x? So we've looked at exponential functions so far. Okay, we know that the 3 right here, this is our y-intercept. And then the 1/4 here, because this is what has the exponent, this is what we're going to be calling our growth factor. Now, because the 1/4 is actually less than the number 1, this is actually not growing at all. So a lot of times this word gets replaced with the word decay. So again, it's growth if the function is growing. If the function, or I'm sorry, is increasing, but if the function is decreasing, that's not really growth. That's the opposite of growth, which we'll use the word decay. Okay, so from this equation, we have both our decay factor and our y-intercept. So it's asking us to graph this. Again, highly recommend make an x, y table. That will make all of your dreams come true. And we have a good starting point here. We can put our y-intercept, okay, is going to have an x value of 0 and a y value of 3. So here we have 0, 1, 2, 3. That's going to be our first point on our graph. Now, this is going to be decaying, so the function is going to look like a hockey stick facing to the right. Now, one way that I can go about getting this is to go ahead and plug in any x value that I'd like. Now, if I plug in 1, be prepared to deal with function or to deal with fractions here. We have 3 times 1/4. If I plug in an x value of 1 into that function, that's going to get me 3 times 1/4, which is 3/4. Now that's a viable point, but it is difficult to graph 3/4. So if I graph 1 times 3/4, that puts me somewhere right around there. Not a perfectly precise point, but if I pick an x value like, let's say, let's try 2. Let's see what 2 gets us. So we're plugging in 2 for x there. 1/4 to the second power is going to be like 1/4 to the second power. And that's going to give us 3 times 1/16. Now this is going to be 3/16. Not a great value here. 3/16. So that's even going to be less than 1/2. So that's right here at 2. That's going to be somewhere down here. Now we could keep making larger x values, but they're just going to keep getting closer and closer to that x-axis here. So what we want to do, we really don't want to worry about that too much, okay? Because that's just going to kind of slowly get closer and closer to my vertical asymptote. I'm sorry, my horizontal asymptote at x at y equals 0. So what we really want to do here is start looking at some values to the left of our starting value, because this is decay. Okay, and if I plug in -1, remember that those negative exponents are going to cause the fraction to reciprocate, to flip. So this is actually going to become 3 times 4 over 1 to the positive 1. Well, 4 over 1 is just 4. So that's going to give us 3 times 4, which is 12. And that number is much easier to plot. The only problem here is we have no 12. Well, that would be the point there. We'll just approximate it. And then we're going to come up here and we're going to draw our hockey stick curve. It's going to get real close to our horizontal asymptote. And of course, we're going to want to represent our horizontal asymptote as well using that dotted line. Okay, so there is our exponential function graphed. Here's our horizontal line. And it asks for the domain here. The domain is going to be all real numbers. The range, though, it is never going to touch that horizontal asymptote. It's going to keep getting closer and closer and closer and closer, but it's never actually going to get there. So for range, it's always above that value. It is never equal to 0. It's getting closer to 0, but it never actually touches 0. So there's no line underneath the greater than sign. Okay, the other option that you would have for range is to do 2 parentheses, soft parentheses, not hard brackets, from 0 to infinity. That would be another option. You don't have to use either one. You can choose which one you'd like. We did say that the y-intercept here is 3. Okay, so we can write either y equals 3, or we can write the point 0, comma 3. Either one of those will work. And then the asymptote here is at the value of y equals 0. It is this horizontal line here. Okay, so that's the warm-up. We're going to jump to the next page. And on this page here, we have a little scenario here, a little guy right here. That's nice. So Jack is a little absent-minded. He was monitoring 2 colonies of bacteria, and he had recorded his data, but then he lost his notebook. All he has left is 2 graphs that he has sketched of the growth models, one for each colony. Can you help him reconstruct his growth models using his sketches? All right, so we have the graph for colony A, we have the graph for colony B. Now both of these are increasing, going up as from left to right, from negative infinity to positive infinity. So these would both be considered exponential growth. It's increasing from left to right. It says X is in time of hours, Y is the number of bacteria in hundreds. So there's our units. And then it says, what are the unknowns in the explicit formula y equals a times b to the x? Remember, here's a little reminder. A is considered our y-intercept, and b is considered our growth factor. Okay? So if we look at colony A, you may want to pause the video now. This would be a good time to see if you can try to fill out both of these as far as unknowns and information. And now I can go ahead and talk about some of this. So if you'll look here in colony A, we can actually visualize right there the y-intercept. It's at 0, 4. So it would not be an unknown. But in colony B, we can see it, but we don't know the actual coordinate point. We don't know the values of x and y. So as far as unknowns go, for colony A, we can't include the y-intercept with A, but we can in colony B. One of the unknowns is the A value, the y-intercept. We can see it, but we don't know what the actual coordinates are. And then as far as the B, the growth factor, we know that they're growing, but we don't necessarily obviously know by how much. We can see this went from 0.4 to 6, 2,916. We can see this went from 212 to 8, 768. But we don't actually know how much each number of hundreds of bacteria increased by what factor. So for colony A, we are going to include the B value, and for colony B, we're going to include the B value. Now, it says, what information do the graphs provide to help us find the unknown? Well, in colony A, we can see that the A value here would be 4. We have the actual coordinate 0, 4. And we also know that for both functions, we can see exponential growth. Can see exponential growth. In other words, as x goes to infinity, y goes to infinity. Same thing over here. As x goes to positive infinity, y goes to positive infinity. That's what's happening with each of these graphs. As I move to the right, as x gets larger, graph goes up. As I move to the right, graph goes up. So that tells us that we do have exponential growth. Go ahead and flip the page to page 18. All right, so we got the same colonies. We have colony A and colony B. Same exact graphs. It does ask us how to determine an explicit formula for each colony. So, explicit formula, that means the rule. That means we're going to have a y equals and then something with an input x. So, we are looking to fill in the gaps for y equals a times b to the x. That's our explicit formula for both. For colony A, we already have half of that taken care of. We already know that the a value, the y-intercept, is 4. So you could go ahead and substitute that on in. We're halfway there. Over here, this is a little bit of a mystery. We're going to have to do a couple different steps here to get that rolling. But let's go ahead and look at colony A. And I'm going to do this by setting up a table here. I'm going to put x, y. And I'm going to start at this point 0, 4. Since I'm growing, I know that it's just going to the left of this, it's just going to get closer and closer to 0. I don't care about any of those points. I only care about how much it's growing by. And the next value we have is at 6, 2,916. So what I'm going to do here, I'm going to leave a blank. I'm actually not going to leave it blank. I'm going to count up my inputs all the way till I get to 6. Why 6? Because that coordinate right there is 6. So I don't know what's at the x value of 1, 2, 3, 4, 5, but I do know that I need to go from 0 to 6. Those are the two known points. So I don't know what this value is for the y value for x equals 1, the y value for x equals 2, 3, 4, 5, but I do know the y value for 6 is 2,916. Now in a table, you are going to be multiplying by the growth factor each time. So to go from 0 to 1, we'd multiply by b, by b, by b. From 3 to 4, let's see, 0 to 1, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. So, let's see, did I do that right? 0, 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Oh, I'm missing one. Sorry about that. So we would have to multiply by b 6 times to get to 2,916. Quick way to figure out how many times that would be is if we're going from an x value of 0 to an x value of 6. How many x values does that change? 6 minus 0 is 6. That's how many times we would be multiplying by b. So I'm going to use that to my advantage, knowing that. I know that we start at 4, and I know that we end up at a value of 2,916. But to go from that, I need to multiply by b, And then we are asking how many times do we multiply by b? 1, 2, 3, 4, 5, 6. 6 times. So now I have the option to actually solve this equation. And since this is multiplication here between the 4 and the b, I can go ahead and do the inverse operation by dividing by 4. That's going to knock out that 4 right there. And that's going to give me b to the 6. And you know what? Let's bring in this guy for today. So we have 2916 divided by 4. And that does give us 729. Now I need to find the b value that multiplied by itself 6 times equals 729. Okay, so in order to undo this b to the 6th, I need to take the 6th root. And because it's an equation, I need to do it on both sides. Now your calculator can do this 2 ways. If I take 729, on the newer TI-84s, the colored one, this method is pretty easy. In the math menu, if you click math, you can see option 5 gives you a chance to choose whichever type of root that you would like to take. So if you click on option 5 in the math menu, you get 2 little areas that you can type. And so we decided we needed to take the 6th root, so the 6 would go there, and then our value 729 is there. And we see we get a value of 3. Now, in your infinite wisdom, you also know that taking the 6th root is the same as having an exponent of 1/6. So if you prefer to use the, and I believe this is a little quicker in the TIs, but if you have an older TI-83, I think this is actually an easier method. If we take 729 and use the caret button, and then parentheses 1 divided by 6, that should get us the same value, 3, and that's what we want. So all that told us was that we have a b value of 3 by solving that equation. Well, we already had our y-intercept was 4. Now we have our growth factor, which is 3 to the power of x. And in case you have a calculator, it's always nice to be able to check this. If you go to the y equals menu and you type in your function 4 times 3 to the x, and you go to your table, second graph, you can actually double check. Here we have an x value of 0. That gives us a y value of 4. That's great. And then we knew that we had an x value of 6, 2,916. So there we have proof from our calculator that what we did was legit. So that was having the y-intercept. Let's go back to colony B now and do this where we actually don't have anything. So I'm going to make another XY table, and the first value in colony B that I have is 2. I'm going to leave some space here because I'm going to show you one method that you can use to actually find that y-intercept that we don't have. I'm going to show you multiple methods, and depending on the scenario, there may be one that is easier to use, but I'm going to leave that up to you and see how which method you like the best. So we start at 2, and we have to get all the way to 8. That's our values for our x. 2. So we have 2, 3, 4, 5, 6, 7, and 8. Now, I left some space here because the y-intercept, as you can see over here on this xy table, the y-intercept is going to happen when x is 0. So if you love the table method and you have a number like 2 that's not very far from 0, you could actually count backwards to try to get to 0, and I'll show you how we can use the pattern to do that. But as of right now, all we know is that the value of 2, the x value of 2 gives us a y value of 12, and the x value of 8 gives us a y value of 768. Now, for 3, unknown, 4 is unknown, 5 is unknown, 6 is unknown, and 7 is unknown for now. So I just put question marks there. And what we're doing here is we're going to, each time, just like we did in the previous one, we're going to multiply by b. To go from 2 to 3, we multiply it by b. 3 to 4, multiply by b, etc., etc., etc. And if you look here, to go from 212 to 8768, I multiplied by b 1, 2, 3, 4, 5, 6 times. So obviously that's a lot of writing. There is a quicker way of getting that. Think about it for a second. How could you figure out that multiplying, or how could you figure out how many times we needed to multiply to go from 2 to 8? So the answer is, if you look at your x values, where you want to go and where you started from, 8 to 2, if you subtract those, you do get 6, which is the number of times that we would have to multiply by b. So let's start out here. 212. Now, in order to actually fully get this this equation, we will find a, but we don't need a to find b. So what I'm going to do here is set up this equation. I'm going to use my y value here, 12, and I multiplied 12 times b, and we found that I multiplied it times b 6 times. That's from counting this. And that got me from 12 all the way to 768. So again, we're solving this equation. Now, start out here. We want to undo that multiplication. We'll divide by 12. We'll bring our good buddy back here. 768 divided by 12 does give us 64. So that tells us that b to the 6th power is 64. And again, you can use whichever method you'd like for calculating this in the calculator. If we want to do the 6th root, we can go to Math 5, type in 6, 64, and that gives us 2. Or if we want to do 64 to the power of 1/2, I'm sorry, power of 1/6. If I was there, somebody would have earned a Jolly Rancher for correcting me, but we do get a value of 2. That means here, this b value every time is actually multiplied by 2. That's our b value. So b, when we took the 6th root of both sides, we got b equals 2. Now, we know what this value is. We know this is 2. Okay, but now we still need to find our a value. So one method that you can use for this, I'll show you this method here, is if we're multiplying by 2 to go down the table, if we're trying to find when x is 0, we need to actually go up the table. So the inverse of that, to go the inverse direction, would be to divide by 2. So if I want to go from 12 to the previous y value, we would divide by 2. And that would give us 6. And then if I want to go from 6 back to 0, we would divide by 2. Again, because we're going up the table. So 6 divided by 2 would give us 3. And that's just a kind of a clever way of using your table to get your y-intercept here. So now we have our explicit equation. We know what our a value is 3. And we know what our b value was 2. Okay, so now you can see the colony A and colony B. Okay, which one had a greater growth factor? The answer would be colony A. Our growth factor here was 3. Our growth factor here was 2. Okay, so now we're going to flip over to the next page. The next page looks very similar to your homework, so you're going to want to pay close attention to this. All right, get some more math in my life. Mathematics on the inside of the coffee. All right, so we are on now page 19, which is the page before your homework, page 20. As you can see, the format is almost identical, so this would be a good this would be a good piece to focus on. So, it says, well, you can't read that because it's been hole punched, but it says write the equation of each exponential function given 2 points. So let's look at some methods to do this. We just spent the previous page building a table. I'm going to look at my points in a table. I like vertical tables, so I'm going to do it vertically like this. Excuse me. So, you want to look for x values of zeros. That gets you half of the way. Remember our equation, a times b to the x. A is the y-intercept, and b is our growth factor. So, we have a times b to the x. If you find an x value of 0, that's giving you some real good information, because that means that whatever the y value is, in this case it's -3, is actually our y-intercept. So I can substitute that in for a. Now this one right here is pretty simple. It's not trying to hide or do anything tricky. All we have to figure out is what our growth factor is. So from 0 to 1, that's just 1. But from -3 to -6, what are we multiplying by? What's the pattern here? And if you said 2, you are correct. Don't get tricked up with the negatives. I guess that could be considered tricky. But right here, this multiplied by 2, just because this difference right here between 0 and 1 is just 1, that becomes our growth factor. So our final answer here is -3, our y-intercept, times 2 to the power of x. Now, number 2, we will create another table. -1, 0.4, and 0.4. Okay, so you can think of this in one of two ways. I'm actually going to do two different tables here, because if you are a fan of fractions, you might like to write 4.4 as 4/10. Sometimes that will actually help find what our actual growth factor is. If you also think about decimals here, there's a really good number that moves decimals around. That number would be 10. When you multiply by 10, you do end up moving the decimal, which is nice because the other values don't change. So from -1 to 0, that's just going up 1. That's nice. That means we don't really have to worry about a whole lot as far as what we're multiplying by. And to go from 0.4 to 4, we move the decimal once to the right, which is the same as multiplying by a value of 10. If you look at it in the fraction world, how would you get rid of a denominator of 10? You just multiply by 10. Sometimes that's a little bit nicer to see. And either way, we do get the same b value. And I thought that finding the b value here was actually simpler. That's why I didn't go with a first. So now we have our a value, our y-intercept. Now again, we're searching for that 0. We don't start with the 0, that's -1, but here it does give us a 0x value with the value of 4 is y. So that's going to go into our a position here. It's our y-intercept. Number 3, they put it in a table for us. It's like they've been listening. Wonderful. Okay, so here, again, that's +1. That makes our lives easy. I'm going to write, I'm going to write it right here so that you remember what the explicit equation is. And then we can also look for the multiplier here, from 2 to 20. From 2 to 20, that's multiplying by 10. That would be our b value. Here's a little hint. If you're trying to figure out what you're multiplying by as you are going down the table, you can do the inverse operation, which is division, the second value divided by the first. If you do 20 divided by 2, hey, that gets you 10. Now, I would hope that we'd be able to see 2 times 10 is 20 here, but this is a foolproof way of finding that value. So, we know here that our b value is going to be 10. We have not found our a value yet. Now, this is a good time to probably use that little 0 trick. So, if we were at 0, we'd be going up the table, so 0, 1, 2, and I'm divided, or I multiplied by 10 to go down the table, so to go up the table I'd have to do the inverse of that, which is dividing by 10. So 2 divided by 10 is the same as 1/5. Or if you took this to the decimal world, that would be 0.20. So most of the time with exponential functions, we are going to welcome fractions to our life, but this would be 1/5. We do want to reduce that. So 1/5 times our growth factor was 10 here. We start at 1/5. Number 4 has got its own unique challenge because now we are in a world where we don't have a table that has 0 in it. So what I'm going to do is come over here and make my own table, because why not? 1, 2, 3, 4, 5, 6, 7. All right. And our value at -1 is 1/2. Our value at 7 is 1/28. And we don't know what these values are. These are question marks. Okay? But looky there, there's 0. That's what we want to find, because that's going to be our A value. Okay? So again, if you like counting, I mean, who doesn't? That's a lot of times B's. If you count them up, that's one way of doing it. The other way of doing it, which I'll show now, is to take our 7 and subtract away our starting point, -1. 7 minus -1 becomes 7 plus 1, which is 8. That's great. That means that we multiplied 1, 2, 3, 4, 5, 6, 7, 8 times B 8 times. Which means, let's see here, we're going to set this up 1/2 times B to the 8th power gave us 128. So we started at 1/2, we multiplied by B 8 times, and we got 128. Now, to get rid of this 1/2, multiply by the reciprocal, which is just 2, or 2/1. And we get B to the 8th equals 128. Use my calculator to make sure I got this, 256. Lovely. So we'll take 256, and I'll use the I will use the 1/8 method, and we can get the 8th root of 256 is actually 2. So there's our B value. We need to find our A value. So let's use the table method. If we know that our B value is 2, we can do 1/2 times 2, which would actually give us 1. And that puts us right at 0. 1/2 times 2 is 1. This point right here, that is our A value, 1. Now, here I wrote the 1. You don't have to write the 1. You could just write 2 to the x, and that would be perfectly fine. Now, number 5, no table. We're going to create our own. I'm going to include 0 because eventually I'm going to want that point. But this one actually starts at 1, and it goes to 5. Okay, so at 1 we have a value of 1/2. At 5 we have a value at 8. We do not know 2, 3, or 4 right now. If you like counting, that means we'd have to multiply by B 4 times to get there. We could also do 5 minus 1 gets us 4. Either method that you'd like to use is acceptable. Now, we start at 1. We have a value of 1/2. We multiply by B 4 times. That's from that 4, and that gets us to our goal of 8. So do a little solving here. We'll multiply both sides by 2 to cancel that out. I get b to the fourth is equal to 16? Fourth root of 16. Any guesses? I'll show this. So I'll use this method this time. Fourth and 16. That does give us 2. Common occurrence here. 2 is our growth factor. Okay, so we have y equals a times b to the x. So that gives us our growth factor is 2, but we still need our a value. Well, we have the value of 1. We need to work our way backwards to get to the value of 0. And since our b value is 2, that means going up the table, we'd have to divide by 2. And 1/2 divided by 2 will give you 1/4. 1/2 divided by 2, divided by 2 gives us 0.25. Math enter, enter, does give us a fraction of 1/4. So our a value in this case is 1/4. Lovely. Could probably throw fraction or parentheses around there, around the fraction. And then lastly, we have number 6 here. I'm going to make another xy table. It goes from -2 to +3. So -2, -1, 0, 1, 2, and 3. And at -2, it's 1 over 100. At 3, it's 1,000. We don't know what -1 is, 0, 1, or 2. We don't truly even really care. But we do want to find our explicit equation. And we can see here we go from 1 over 100. We multiply by b. Looks like 5 times. Let's check that. 3 minus -2. That gives us 3 plus 2, which is 5. That's good. So we multiply by b 5 times. And that got us to a result of 1,000. So solving this equation here, we'll multiply by 100. That'll knock that out, knock that out. Multiplying numbers with a bunch of zeros, just add up the zeros. So b to the 5th equals 1, 1, 2, 3, 4, 5. So that's 100,000. And so we'll do 100,000 to the, we're looking at the 5th root here, so to the 1/5. That gives us 10. Hey, that's nice. Imagine that. 5 zeros, 5th root, gives us 10. So, I have my b value. That's going to go right here. But I need my a value. So let's use that b value here. 1 over 100 times 10 is 0.1. In other words, as a fraction, that's 1/10. Okay, 1/10 times 10 gives you just 1. And that right there, using that, gives us our a value. So that's an optional inclusion into our equation. I'll write it just to have it there. So that's 1 times 10 to the x. That 1 is optional. So another acceptable answer would have just been y equals 10 to the x. Okay, so you have 6 examples here. Tonight's homework will be 1 through 6. You can start working on that now. All right. Have a good one. Much love. Mathematics. Enjoy. I'd say 23 hours, but oh, I just spilled coffee. That's not good. Oh gosh. Somebody see a paper towel? Oh man. Mathematics. Is this thing even on?